Welcome to Ride On Academia. Today we are going to be looking at differentiation, and in this very video we are going to be doing an introduction to differentiation. So I'm going to be showing you how to differentiate in this particular edition. Differentiation simply means finding the differential coefficient of a given function. Okay, we are finding the differential coefficient of a given function. Our symbol is simply dy dx. Okay, this simply means that we are differentiating y. We are differentiating y with respect to x. Okay, we are differentiating y with respect to x. So let's assume a function is given to us where our y is equal to, let's say, x raised to power 4. Okay, this is trying to show us that y will be varying as the value of x increases, the value of y will also change, right? So if we're asked to find the coefficient or the differential coefficient of y, that is to differentiate y with respect to x, I'm going to be showing us quickly how to differentiate. Now, using our general principle, okay, using our general principle, what we do is we multiply the power, okay, by the coefficient. That's the first. The coefficient here is 1, right? Because it's 1 times x to give us x, right? We multiply the power by the coefficient of our variable, and then we reduce 1 from the power. So we can simply put multiply and reduce. Okay, multiply and subtract. You can use it like that. So if we want to differentiate with respect to our x, okay, to differentiate y with respect to x, what we simply do is that we multiply. Okay, so we'll be having our differentiation dy dx. Okay, to be giving us what? We multiply 4 by the coefficient, which is 1. We'll be having 4x, right? And then we subtract 1 from the power. Okay, this is how we differentiate. We multiply and then we subtract 1. As we multiply, we are reducing 1. Okay, we're reducing the power by 1. So when we do this, our dy dx will be giving us 4x raised to power of 3. And we have successfully differentiated our y with respect to x. So I'm going to show you another example. We are having that x raised to power 3 minus 5x squared plus 3x minus 2. Okay, this is our y. Our y is equal to this. And we are asked to differentiate y with respect to x. Now, we're going to be differentiating. Like I said, what we just do, we multiply and then we reduce 1 from the power. Okay, so what do we do? Our dy dx, we multiply, right? The coefficient here remains 1. So we'll be having 3x raised to power 3 minus 1. Okay, let's use bracket to avoid confusion. Then we have minus 5, right? 5 times 2, we have 10 minus 10 raised to power of x raised to power 2 minus 1. Okay, minus 10x raised to power 2 minus 1. And then we have plus 3. Now the power of our x here is 1, right? So we have 1 times 3 to give us 3. And then x raised to power 1 minus 1, right? And then lastly, now the power of our x here is 0, right? Because anything raised to power 0 is 1. So if we want to multiply, we'll be having 0 times 2 to give us 0. Okay, so anything multiplied by 0 will be eventually leading to 0. And that's the reason why when we have a constant is differentiated to 0, because the power of the variable here is 0. So when we multiply 0 by anything, it gives us 0. So that one, a constant, to be giving us what? 0. When we differentiate any constant, our answer must be equal to 0. So we have done this. We can continue, right? Okay, we can continue. Now let's solve this. We'll be having our dy dx to be giving us 3x. 3 minus 1, we have 2. And then we have 10 minus 1, we have just 1, that is 10x. And then plus 3. Okay, 1 minus 1 is 0. So raised to power 0 is 1. Okay, so we have 3 times 1 to be giving us 3. And then we have successfully differentiated our variable. Okay, we are differentiating our y with our respect to x. Now the third example I'm going to be taking is going to be a bit complicated. We have y. We can use any other variable, okay, but many times we use y. Okay, we have y to be equal to 2x raised to power 7 minus 6x raised to power minus 3, right? And then we have plus 1 over x raised to power 2. Okay, and we are asked to differentiate this. we're asked to differentiate y with respect to x. All right, now like I said, what we simply do in differentiation, using our general principle, we multiply by the power and then we reduce one from the power. Okay, now we're doing the same thing. Now in our indices, we have seen something concerning this. We have seen something called the negative power law. Yes, I'm going to be having to remind us of that, okay, in respect to this question. We have something like the negative power law, where if we have, let's assume we have x raised to the power 1 over 2. This is our power. Because of our minus, we make it to be 1 over x raised to the power 1 over 2. Because of the minus, it becomes a fraction, right? So we're going to be applying that here in this question. So we'll be having that our y is equal to 2x raised to the power 7 minus 6x raised to the power minus 3, and then plus. Now let's use that power. I'll be converting this back to our negative power. Okay, so since it's 2, okay, we'll be having x raised to the power minus 2. All right, now we can differentiate our dy dx. Now multiply by the power quickly. We have 7 times 2, we have 14x, and then when we less 1 from 7, we have 6. 14x raised to the power 6. For the next person, minus 3 times minus 6, minus becomes plus, right? So we have plus 18. Then we have minus 3 minus 1. Okay, now we have minus 3 minus 1. We are reducing 1 from the power. So when we have minus 3 minus 1, it becomes minus 4. All right, you must note this. It becomes minus 4. So we have x raised to the power minus 4. And then for the last person, minus 2 times plus 1, the coefficient here is 1, right? Minus 2 times plus 1, we'll be having minus 2x, right? And then we are lessing 1 from the power. So minus 2 minus 1, we're giving us minus 3. All right? Yes. We've gotten minus 3. And then you can leave it in this form, or if you want to use negative power law to bring it in this format, we'll be having dy dx to be equal to 14x raised to the power 6 plus, we can simply say this is what, 18 times 1 over x raised to the power 4 minus 2 times 1 over x raised to the power 3. All right, now this is over 1 over 1, so we can make it a single fraction, right? We'll be having our dy dx to be equal to 14x raised to the power 6. Then 18 times 1, we have plus 18 x raised to over x raised to the power 4. And then lastly, minus 2 times 1, we'll be having minus 2, right, over x raised to the power 3. And then we have successfully differentiated this. All right? We have differentiated our y in respect to x. So in this video, we have successfully looked at how to differentiate. If you've not liked our channel, if you've not been liking our videos, you've not subscribed to this channel, you've not clicked our notification button, you've not been sharing, please do so. Okay, now we'll see you in our next class. Thank you.